Hello and welcome to another Mr. Marriott Maths video. This time we're attempting question 3 of the October 2021 Edexcel decision maths paper. So table 1 shows the shortest distances in miles between 8 towns A, B, C, D, E, F, G and H. And we're asked to use Prim's algorithm starting at A to find the minimum spanning tree for this table of distances. And you must clearly state the order in which you select the edges of your tree. So I'm going to add A to my minimum spanning tree, so I'm going to label column A with 1. I'm going to cross out row A. And I'm going to select the smallest value that's not crossed out in any of my labelled columns. And the smallest value is going to be this 22 here. So I'm going to make it clear that I've added AH with weight 22. Which means I'm now connecting H to my tree. So H is being added second, and I'm crossing out row H because I no longer need to connect H. The smallest value in columns A and H is now going to be this 24 here. So I'm connecting AB with weight 24. So I can cross out row B because I no longer need to connect B to my tree, and I'm adding B third. And now the smallest value in columns A, B and H seems to be this 27 here. I'm going to make sure that 27 is the smallest by looking up and down all three columns, and 27 is the smallest. So I'm adding HD next, 27. So I'm going to cross out row D, and I'm going to label column D with a 4. I'm going to carry this one on. So now, what is the smallest value in any of these 4 columns? And it looks to be this 21. I'm going to circle it and add DC, 21. I'm going to cross out row C, and I'm going to label column C with a 5. Now I need to see which is the smallest value in columns A, B, C, D and H. And that appears to be this 26. I can't see any value smaller than this 26. I'm going to circle the 26. I'm going to write CE 26. And I'm going to cross out row E. I'm going to label column E with a 6. Next up, what's the smallest value in any of these 6 columns that's not crossed out? And upon inspection, it appears to be 29. So I'm going to circle a 29. I'm going to record DG 29. I'm going to cross out row G. And I'm going to label column G with a 7. Now, what's the smallest value that's not crossed out in any of these 7 columns? And it is just the smallest value left in this row. And it appears to be 34, which belongs to EF. So I'm going to cross out row F, and I'm going to label column F just to confirm that I have done this. So, marks. First method mark will have come from choosing the first 3 arcs correctly in order. So if you chose AH, AB and HD. Or the first 4 nodes chosen in order A, H, B and D. So it can either be seen with the 3 edges selected, or it can be seen with the numbers 1, 2, 3 and 4 above the correct columns. Next accuracy mark comes from having the first 5 arcs correctly added, or 6 vertices correctly labelled. So 1, 2, 3, 4, 5, and 6. The final accuracy mark comes from having all arcs correctly stated and chosen in order. This can be seen from the question or from your diagram, but this number 8 must be present. That's going to be the final accuracy mark. Okay, moving on to question B, and we're asked to state the weight of a minimum spanning tree. You just need to add up all of the weights of the 7 edges added. And if you do that, we're going to get the minimum weight of the weight of a minimum spanning tree is 183. Units would be a really nice thing to state. We're told the units are miles, but that's not necessary for a mark in a decision exam. And this is an independent accuracy mark. Okay, question C. We're now asked to start at J to use the nearest neighbour algorithm to obtain an upper bound for the length of a route that Pranav needs to visit all the towns, starting and finishing at J. And we're told that J has these distances to towns A, B, C, D, E, F, G, and H. So if we're starting at J, we're just going to visit the nearest neighbour to J. The nearest neighbour to J is F. So we're going to go J, F, and now we're on to the main matrix. We won't return to J until all these other towns have been visited. So we can apply the nearest neighbour algorithm to this diagram, to this matrix. So we've got J to F. We've visited F, the nearest neighbour to F. We can see 37, 37, 34. The nearest neighbour is E. So I'm going to cross out row F because I've visited F. And I'm going to go to E next. And I'm going to cross out E as well. So I'm now at E. And I need to visit the nearest neighbour to E that I've not yet visited. I've got 34, 30, 26. 26 seems to be the smallest. So I'm going to go E to C next. I'm going to cross out C. And I'm going to consider C to another vertex. I've got 42, 40, 21, and 21 seems to be the best. So I'm going to go from C to D. I'm going to cross out D, and I'm going to consider column D now. 48, 35, 29, 27. I'm going to go to H. I'm going to cross out H, and I'm going to consider column H. 22 is the smallest. I'm going to go to A. I'm going to cross out A, and I'm going to look at column A. 24 and 32, 24 is smaller. I'm going to go to B. I'm going to cross out B. The only option left is to go to G. I'm going to cross that out. And last but not least, I've got to get back to J. And to get back to J, I need to go from G to J. So I'm going to circle G and 49 as well. So I've got my route J, F, E, C, D, H, A, B, G, and J. But I'm also asked to state the length of this route. And the length of this route is going to be the 25 and the 49 that connects J to the other towns on this route. And it's going to be the other circled values in this table. If you add all of those values up, you should get 267 miles. So this is a 2 marker. You get an independent accuracy mark for writing the order of the towns, and another independent accuracy mark for giving 267 as an answer. Last but not least, we're asked to Start by deleting j and all of its edges. Find a lower bound for the length of Pranav's route. So previously the nearest neighbour algorithm gives us an upper bound. By deleting j and all of its edges, we're using the residual minimum spanning tree. And if we delete j, we're just left with towns A, B, C, D, E, F, G, and H. We already know the minimum spanning tree for those towns. So you can write down MST for A to H, gives us 183 miles. And now we need to connect j using the two shortest edges. So connecting j, the two shortest edges that connect j to any towns A to H are going to be 27, which is B, and 25, which is F. So we've got 27 to B, 25 to F. So we can add these three values up. I'm going to get 235 miles. So you get a method mark for adding 183, 27 and 25. And this does have a follow through element to it. As long as you write down the number you provided in question B plus 27 plus 25, that's going to be a method mark. And you get an accuracy mark for a correct answer only, so 235 only. So thank you for watching, and until next time, have a good day.